Okay, thanks very much. Welcome. I can see a few of you are still taking your seats. That's absolutely fine. This morning I would like to, it's still this morning. This morning I'd like to talk to you about the future of engineering, sustainability, and the questions we should be asking. I thought it would be useful for me to introduce myself first. That might leave you with some questions, very sensible, realistic questions, which hopefully I will answer at the same time. I'd then like to talk about sustainability and some misconceptions that we might have, and some challenges, and maybe challenge you in the room to think a little bit about that. I'd then like to talk to you about something called regenerative design. And lastly, that's not questions as in you can ask me questions. That's questions as in I'd like to ask you some questions and get you thinking about the work that you're doing and the questions you might like to be asking each other today, tomorrow, and also as you proceed in your work. So, a little bit of an introduction to myself. I was a practicing engineer for many years. This is the very first project I worked on back in 2000. And actually what I like about this project is this project actually won a lot of sustainability awards. Already back in 2000 we were talking about sustainability, energy particularly, and how to minimize energy usage through the design of buildings. I worked on a number of different projects, so most of my career I was with a company called Rambo, and I designed a few different things, including the roof of the Ferrari Experience. So the Ferrari Experience itself was approximately £3 billion. My roof was about £300 million, so it was quite a big piece of structure. But I didn't just work on really big things, I worked on medium-sized projects. So I did the John Henry Brooks building, which won all sorts of awards, and is noticeable for all its exposed concrete, and I have to confess I am a huge fan of concrete. It is a material that I really love, and we did lots of work to expose the concrete in a way where the pattern of the formwork is exposed on the concrete in its final condition. And again, this project was very focused around sustainability and energy use and reducing energy use. I've worked on a number of different projects with different materials. So this is a building I designed made out of timber. And in fact, this is my all-time favorite project. This is kind of my #1 project that I worked on. And partly because I love it and I think it's beautiful, partly because of the material it's made from and the story around the project, and partly because it is actually a building at the school where I went to school. So I actually have a kind of a deep personal connection with the project. I also worked on the Tate Modern, so my job was to design the facade of the new extension, which was quite an interesting experience. Unlike most building design, this one involved lots of prototyping. It involved lots of physical testing of the physical facade to make sure it was going to be able to carry the load and work and be buildable with very little in terms of visible movement joints. There are movement joints all over the facade, but they're all invisible. And I left Rambo in 2012, and I joined a company called Integral Engineering Design, and I worked on some very interesting projects with them, a lot of reuse of existing buildings, including this project, which is a round earth wedding venue where the walls are made from earth. It's part of a reuse project, so they were reusing the existing building, but they wanted to have a place where they could have parties, and those parties were going to be really loud. And as you can see, they're in an area of outstanding natural beauty, and so they wanted a building which was completely noise-proof, but also fitted into the landscape. So we ended up designing a building out of earth. I left industry in 2015, and I became an academic, and my work as an academic is mostly focused around trying to engage industry in conversations around sustainability. So I wrote some books. I tried to help industry think about how it could use things like timber much more in its design. So there's 2 timber books. I wrote a book for the Institution of Structural Engineers called The Conceptual Design of Buildings, which tries to help engineers make good decisions from the beginning about how they approach design. And I'm thinking, or I'm wondering if you're thinking, this is all very interesting, James, but what has this got to do with glass fiber reinforced concrete? And the answer is nothing. Nothing at all. And it gets worse, because actually as an academic I've been involved in a number of research projects. So I've done research into lime concrete, I've done research into timber concrete composites, and my most recent research is in bamboo connections. And again, nothing here has anything to do with glass fiber reinforced concrete, although, as you can tell, I am a big fan of concrete, and I do use a lot of concrete in my work. I did when I was in industry, I do as an academic now, do research. But actually the thing I'm really interested in, and the reason I believe I'm here today to talk to you, is I'm interested in sustainability and how we change our cultures, how we change industry, and I have this slightly unusual position, because as an academic, I get to meet lots of different people working in industry, and I get to talk to them about the challenges they face. But most academics haven't spent 15 years working in industry, so I also have the perspective of someone who actually was a building designer. I understand kind of what it means to be a building designer, the pressures. I understand what it means to have clients who are concerned about fees, and they're concerned about project costs. So I'm kind of able to straddle these two spaces and have conversations with people. And I've started to, I don't know what the right word is, maybe ask some questions, let's put it that way. I've started to ask some questions out into industry to challenge people about how they think about building design. And so we started publishing short thought pieces, provocations about how we could approach design differently. So this is just one example. Nothing is better than something, which challenges that idea of why do we always assume we're going to start with a brand new building? Why don't we start thinking about what we can reuse, especially, and I was actually up on the roof at Bristol University yesterday, and I looked out over the city of Bristol, and many of our cities, certainly in the UK, are very material rich. We already have lots of buildings, and therefore, rather than just knocking things down and starting again, why don't we reconsider how we approach things? Now, that's generated lots of conversation, as you can imagine. Not everyone supports my views. I actually don't mind that. What I'm trying to do is get people to question and to think differently, and I hope off the back of this morning, that's what I will achieve in this space. But I must confess, and it is really important to say this, I don't understand the glass fiber reinforced concrete industry in the way that you understand it. I don't have sort of big insights. I don't understand how your supply chains work. I don't understand how your business models work. My role was a design engineer, so I would work in a very different way. I might have interfaced with some of you on some of the projects that I worked on, but I don't have that understanding. And I'm also aware that there's a very global mix of people here, which is very exciting. And most of my projects were UK focused. So things that maybe work in the UK may well not work elsewhere, but often they do. And actually, I was having some very interesting conversations with some people in Rwanda and the Philippines just over the last few weeks about how they are building things. And actually, the number of things that are the same was huge and was very exciting. So I'd like to just throw out some misconceptions. I actually wrote a recent thought piece for the Institute of Civil Engineers called 7 Deadly Misconceptions of the Climate Emergency. The idea was to be provocative, to get people to think, to challenge how people approach their design. The idea was also to kind of riff on the idea of the 7 deadly sins. The point is really the fact that the word deadly is in there. Actually, if we ignore these things, it could have a huge impact, not just for us as individuals, but for the global population and for the animal kingdom and everything else. Misconceptions, things that we maybe don't believe or believe which aren't quite right. And the first one is that this is a new problem. There's been a lot written, certainly in the UK in the last year, about the climate emergency. It's become a hot topic. The Institution of Structural Engineers have really done a great job of telling people about the climate emergency and raising the awareness of the climate emergency. But actually, 2023 is not the year that the climate emergency was first discussed or discovered. This is my hand drawing of the CO2 levels, and they've been rising steadily. So from the 1960s, I was born in 1977, which is about here. where we were at about 330 parts per million. Now, the climate emergency, as far as I can tell, and I'm not a climate scientist, I'm an engineer, I'm looking for solutions to problems, I'm not looking to do the science part, but we started talking about it back in the 1970s. It's been around for about 50 years. This is not a new problem. When I did my first building design in 2000, we were already trying to design for the climate emergency. We were trying to minimize, at that point, the energy usage in the building. So this is not a new thing. This is a very long-term problem that we've been discussing for my entire career. And that is important because if we pretend it's a new thing today, we can't learn from the mistakes we've been making over the last 23 years as to why we haven't done more quickly. The next misconception I come across is that this assumption that if we do it, we will do it better. So I talk to a lot of now consultants in engineering, and I talk to them about the climate emergency, and the thing they always say to me, pretty much, is if we do it, we will do it better. So there's this kind of understanding that maybe I'm going to design a building, and yes, it's not necessarily as kind of climate neutral as I would like it to be, but it will be better than if someone else did it. The problem with that logic is we've kind of been on that conversation now for a decade or so, and the reality is that we've carried on doing everything exactly the same. The average outcome of everyone thinking they'll do it better is exactly the same outcome as where we are now. And it's a little bit like, apparently, and I'm not a psychologist, but most people believe they are a better than average driver. But actually, most people can't be better than average. Most people, you know, some of them are better than average, some of them are worse than average, some of them are average, but you can't all be better than average. It just doesn't work. And in the same way, in terms of the climate emergency, we can't all be doing better than our competitors. In fact, we're probably all doing just about the same as our competitors. The next one, and this one is the one that kind of gets me most frustrated, is this idea that it's for the next generation to solve. So as I said earlier, we knew about global warming 50 years ago. That was before I was born. We knew it was due to human actions 30 years ago, give or take. That was before I became a practicing engineer. We knew it was a complex system problem about 10 years ago when we started to talk about the Sustainable Development Goals. So actually, if you are a practicing engineer, like I'm a practicing or was a practicing engineer, may well be a practicing engineer again, this isn't a problem for the next generation to solve. This is a problem for our generation to solve. The last two generations have decided not to solve the problem and pass it on. We cannot keep doing that. It doesn't work. We're not going to get to the solution we need to get to by doing that. Which then leads me to, it's for educators to teach. I left industry to become an educator, to teach other people how to design buildings in a way which was more sustainable. At the time, I genuinely believed, and I still think it does have an impact. But what I've realized over the last, I've been involved in teaching sustainable design for about 12 years, is that actually there's no point teaching graduates how to be brilliant engineers and who can think about sustainability and the climate emergency if the company that they go into are not then interested in engaging in those conversations. So actually, I've changed my perspective, I've changed my position. I'm now much more interested in talking to people in industry, people like yourselves, than I am talking about to graduates, because graduates already know about the climate emergency. They're already worried about the future. What they're not getting is the people above them, their bosses, their directors, who are then giving them permission to do the things that they want to do. So I can teach people about sustainability, but it's no use if there's no actual action happening once they leave and work in industry. This is one of those misconceptions which I think is kind of maybe a bit of an elephant in the room. And I know this because I've been there. I've worked in industry. I've tried to do lots of different things around sustainability, but there is always this pressure to leave work at the end of the day with a salary. And so there's this misconception that if someone would pay us, we would do it differently. But actually the reality is there are lots of great solutions out there which are financially viable, which we could do. They might require us to take some risks. They might require us to do a bit more work or a bit more research. But actually there are amazing solutions out there which people will pay for And actually, this isn't true that people just wouldn't pay. That isn't actually true. It's not up to me. It's up to, and you can add a name of any big organization, institution. You could, maybe the GRCA, maybe it's up to them. It's not up to me. It's not up to my company. It's up to the government, or it's up to the institutions, or structural engineers or civil engineers. And this is true. Of course, it is up to them to do things. But actually, we shouldn't use that an excuse to not then do anything ourselves. We all have a part to play. I'm not in any way suggesting it is completely on any one of us to solve the world's problems. But just because it's not on any one of us individually to solve the world's problems doesn't mean we, and I include myself absolutely in that, we can all have a part to play in actually changing the way we do things, and therefore how we approach design and change the course of the climate emergency. And of course, probably one of the ones that is starting to come up more and more is it's too late. We've kind of missed the boat. So why bother? Why not just give up and carry on with business as usual? Because actually there's nothing we can do. And it is late. Don't get me wrong. We've been not doing things for a very long time. And it is late. And as a result, there will be consequences as far as I can tell. As I said, I'm not a scientist, I'm an engineer. But when I read predictions by scientists, I think we have to understand that there will be consequences. But it doesn't mean that those consequences can't be reduced or mitigated by our actions. So for me, I plan on not at all giving up and doing all I can to engage in conversations around the climate emergency. And I'd love for that to be true for you as well. So where is all of this going? I've talked about kind of some misconceptions. I don't know how you're feeling. I'm looking out in the room. It's quite a serious space. I feel like I may have made everyone feel a bit rubbish, and it wasn't my intention. My intention is to just be honest about where we are and to say I've stood in that space. I do stand in that space with you. I've shared these misconceptions. I've had those conversations with my clients, with my bosses, but there is ways forward. And for me, my aha moment, I hope I spelled that right. I spent ages trying to work out how to spell it without coming up with the name of a Norwegian rock band. But my aha moment, which is a moment of realization, suddenly realizing what there is going on. For me, it came reading this book, Donut Economics, which I found really helpful. And I found it particularly helpful for this reason. I don't know if you've seen this graph. It's been a lot in the sustainability publications of the last few years. You'll see it in things like PAS 2080 and a whole load of others, where we have kind of on one axis how far in we are to a project. So we've got the planning, the design, the construction, and the operation and maintenance. And for you guys, designing with glass fiber, reinforced concrete, you might be in that build clever space. Or you might be in the build less space. You might actually be able to reduce the amount of materials that need to go into a building by the products that you're using. Or even, like I said at the beginning, we might build nothing and actually have 100% impact. The problem is that there is an assumption here in this diagram that all construction has a negative impact on the environment, that there is no way of doing things differently. And so my aha moment was realizing, oh, wait, there's a space the other side of the line. That we don't just have negative impacts. That we don't just have the do nothing, do what pays, do your fair share, do no harm, but there's this space above the line. And that's conceptually quite hard for us to understand because we may not have seen very many examples of what that might look like. And so I've been researching into this area of regenerative design. Now, I don't want to spend the next 35 minutes, well, actually I've only got 10 minutes. I don't want to spend the next 10 minutes just telling you about regenerative design. But if you want to take a photo, then please do, and maybe you can go and read them. The word on the left, Restore, Regenesis, and Carol Sanford, these are 3 different schools of thought. These are different kind of organizations who shared their own view of what regenerative design is. For me, the exciting one is Carol Sanford's. And actually, I think maybe for you guys, this is an exciting opportunity. And I'm going to flip it around. So Carol Sanford says, design thinking emphasizes problem solving as a way of arresting disorder. And I think that is what I tended to do when I was a structural engineer. I was working with problems. I was trying to solve those problems and create buildings. Whereas regenerative design begins from the unique and specific potential of a situation and works to develop the capacity to bring this potential forward. And for you guys, glass fiber reinforced concrete, I'm sure there are some negatives in terms of the environmental impact, but there are also some positives. It can be much lighter than current materials if we were to look at it, and there must be positives in terms of the future potential for reuse or thinking about recycling. And you have an opportunity to think about the unique and specific potential and how your material could be used differently. Now, you might think, what has this got to do with structural engineering? Well, the UK Structural Engineers Declare movement actually talks about regenerative design. So you may or may not have seen this, you may or not have come across this. I imagine some of your clients or some of your specifiers, should I say, some of the structural engineers who are specifying your materials or the architects who are specifying your materials have signed up to this. And they are probably scratching their head going, how do we actually deliver this? So if you can start to have conversations with them about this and actually get ahead of the curve, you can actually help them when they specify their materials to think about regenerative design. So this is an opportunity for you. This is not a negative, this is a positive. This is a chance for you to think differently, which is why I'd like to give you some questions that you might like to be thinking about. And regenerative design comes up twice in the kind of bullet points of what this organization is about, but also it comes up right in the title. The UK Structural Engineers declare a climate and biodiversity emergency. It's not a climate, kind of separate and then a separate biodiversity. These things are interlinked. They are connected. When we solve one, we need to solve the other. We need to be thinking systematically about our approach, which then takes us to the Sustainable Development Goals. These are not new. They've been around for a fair while, which is all about systems thinking and how do we interconnect our thinking and enable sustainable cities and communities. That is right in the ballpark of what we're doing. How do we think about that? But could we also be thinking about health or poverty? Could we think about climate action, renewable energy? How are these things interconnected, and how does our work sit across multiple of these? Now, if you're interested in this space, and I would hope that you would be, you might find some of these books useful, including, this is my book. As you can see, it's a bunch of papers with some scribbles on it. That's because it's currently in its second draft. We're hoping to publish it by the end of this year, and that's about regenerative design for my people, and probably the people who are specifying your products, which is structural engineers. So, I've hopefully given you a glimpse of where we might be going and the sort of things, the approach we might take, this more systems approach, this regenerative approach. So I gave you 7 deadly misconceptions. Now there are 7 questions we could ask. And I suspect you've answered this much better than I could answer this. Have you followed your materials all the way back to the source? Engineers, structural engineers, people like me who sat in offices designing buildings and writing specifications and sending them out to contractors who would then send them to subcontractors who would then cost it and potentially buy products from a series of, kind of further subcontractors who would then deliver them to subcontractors who would build it for the contractor on behalf of the designer for the client. As designers, we are very disconnected from materials. The point really fell home for me when I read this book. This is a brilliant book. You might be thinking, what the heck is that? And you'd be right to think about. This is a toaster. This is a toaster built by an art student, and he tried to build the entire toaster from scratch. So his question was, I could buy a toaster for £4. How is it so cheap? How could you do that so cheaply? And could I try and replicate the process of making a toaster? So he goes and collects materials from around the world. He collects copper from copper mines. He collects iron ore from mines. He collects all of the different materials. He tries to make plastic and all sorts of things. It's a very good book. It's very funny. I really enjoyed it. But the point is, Do we really understand where our materials come from? And do we understand our supply chains? And do we understand the impact environmentally? Do we understand the impact socially of the places of our supply chains? And are we really asking questions about that? And for me as a specifier, I know that I never did when I worked in industry. That was never something I thought about. Now, as I say, for you guys, you are in a different point in the supply chain. You might know much better. I was talking to Richard, and in fact, Richard is just based around the corner from this. This is Avonmouth, which is the docks in Bristol. I'm at Bristol University, where a lot of the materials come in that we are using in the UK in our construction. And we thought, I've designed concrete buildings, you've seen loads of them. I've never asked the question, where did the materials come from? So I thought I'd go and find out. And I jumped on a train and we went and had a look. And the thing I noticed about being here is that it has an impact on the environment. You can literally feel it on your eyes and you can smell it and taste it when you're this close to the docks. It has an impact. And I'd never understood that when I was a structural engineer designing buildings, and I discovered it. So do we understand our supply chain? And then, once we understand our supply chain, how can we minimize the negative impact? And that isn't just about the climate emergency. It might be around chemical pollution. It might be around freshwater withdrawals. It might be around biodiversity loss. There are lots of different ways we can understand the impact that our supply chain has. And how can we maximize the positive impact? Are we creating income and work? And I hope, and I'm sure you are. Are we creating housing? Are we creating places for health and education, for social equity? As engineers, that's what we're doing. We're building buildings which has a positive impact. So how can we kind of optimize and maximize our positive impact, but also recognize the negative impact? And then how can we collaborate and share ideas? It's great that you're all in the room together. This is a picture of the guy who invented the seatbelt, I hope. I just Googled it, and this is what came up. Now, Volvo, famously, when they invented the seatbelt, or the three-point seatbelt, they could have kept that idea to themselves. They could have said, our cars are safer than everyone else's. We have a unique selling point, which means that you should buy our cars, not anyone else's. It will be better for us if we do that. But they were like, this invention is so important, we've got to give it away. Every car now has this kind of seatbelt, or most cars. So actually, when we're starting to think about the environment, when we're thinking about sustainability, how can we collaborate? How can we give things away? How can we avoid having a unique selling point? And just as a specifier of materials, I hated it when people had a unique selling point, because it made it very difficult for me to specify their material, because my contractor would say, well, that's not going to be competitive. So actually, if you're sharing ideas and you're sharing your unique selling points and you're giving ideas to each other, not only are you actually doing good things, thank you very much, 2 minutes, you're also potentially growing the market. Actually, it will be good for you, not bad for you. So how can we do that? What opportunities are there for creating circularity? So regenerative design isn't about circularity, but circularity comes up a lot. And if you're not already thinking about circularity, I would strongly encourage you to. You're circular, you're on the right-hand side, I suspect, in terms of the use of materials which are finite. So how can we recycle, refurbish, reuse, maintain and prolong? How can we do all of these things in our design and manufacture of our materials? What are you already doing but not celebrating? One of the things I learned working in industry is people do great stuff and then don't tell anyone. Or they stop telling people after a year or so because they get bored, because they're like, everyone knows this now. What I discovered is that not everyone knows this, and there are lots of great stories to tell. I was talking to Richard in the build-up to this, and we were discussing how actually there are probably already some great stories that you as an industry, you as an organization haven't necessarily spoken about enough in terms of reducing material use, in terms of then if you're making buildings lighter, you can reduce foundations, you can start to do things. So what are the stories that you're not already thinking about and celebrating? That doesn't mean just do that stuff. You still need to do all the other stuff, but do celebrate the wins. And to finish, what other questions should we be asking? So I don't know about your industry, you know about your industry. I've given you some questions to think about, but I'm sure you have loads of other questions which you should be discussing over lunch in about 45 minutes' time. And I'm done. Oh, I'm 30 seconds over.